Hi, so today I'm just going to talk a little bit about using DevOps techniques with infrastructure as code. So this comes out of sort of my personal experience. Not all of it is going to be right. Some people might disagree, but this is based on sort of the mileage I've had. So first, a little bit about me and what I do. So I work for PA Consulting. I'm the lead across for our partnership with Amazon, so I work very closely with Amazon. I've been working with AWS for a good few years now, and I currently work across a lot of our different projects internally. So as well as based on a client site doing a lot of delivery work, I work on like consulting internally, doing DevOps, IoT, machine learning projects, work across a lot of proof of concepts and training internally. So PA is an advanced consulting partner, and we work across a whole range of different AWS products and services. So quickly, what is Internet of Things? So Internet of Things is one of these buzzwords that you'll hear a hell of a lot about these days. Everyone's talking about it. And a lot of people mean a lot of different things. So just a little bit of a snapshot of some of the work we're doing with Internet of Things at PA. And this is, hopefully relatively reflective of the market. So Internet of Things has great potential to actually change people's lives and change the world we live in. So some of the things we're working on is smart homes with various councils. So that's helping them manage their housing stocks. So quite often, councils are managing hundreds of homes. Their data's normally not up to date, so they don't actually know which of their homes are vacant, which of them have problems. So by putting a few simple sensors in a home, you can tell whether it's occupied by looking at things like the heating and the lighting. You can tell whether there's leaks by looking at things like the relative humidity in different rooms. So you can do a lot of very non-intrusive things to actually give councils a very good overview of a large housing portfolio. Another big area at the moment we're seeing a lot in is assisted living. So this is helping people stay in their homes for longer. So there's a lot of adult social, in the adult social care place. People actually want to stay in their homes. They don't want to be in care homes. But it's very, very difficult to look after lots of people in the community. So being able to actually use devices to make sure people have actually got out of bed that day. If someone's not moving around the house, have they had a fall? So it's information like that then helps the care teams responsible check in on these people in as non-intrusive a way as possible. It also is very cost efficient for the councils as well. So everything the councils do these days, they're always looking at how they can make public money go further. So another one is manufacturing, being able to monitor all parts of a production line. Quite often then you can start doing preventative maintenance. You can actually spot problems before they occur, and you can help improve the productivity and efficiency. Another area we're seeing a lot in is sort of medical devices. So there's a lot of monitoring around there to make sure medical devices are functioning correctly. And then one which was quite a fun one, what we worked on a project for recently, is cashless money boxes. So it's very important these days in this new cashless society that's emerging for children to be able to manage their money, because otherwise children will grow up without an understanding of money and won't realise that there actually has to be more money coming in than going out if you want to be able to manage your money. So when children now are getting online gifts from parents, grandparents, or pocket money might be paid to them digitally, actually having some way that they can interact with the bank is quite an important thing. And then one thing that bit of IoT that I've never had anything to do with is sort of the toys and the gimmicks market. I think from a commercial point of view that doesn't really it's a very small area. It's probably what you hear about the most. They're normally things that there's not a great value in. So hopefully we won't be talking too much about the good old internet kettle. So why did I start looking at using DevOps with IoT? So it all started out first with when I was prototyping some things, actually a response to the pain. So AWS have made a lovely device. It's called the DeepLens. If people didn't know this, DeepLens is actually running Greengrass Core inside it. And you can do all sorts of fun projects with the DeepLens where you are doing sort of machine learning at the edge. Very good fun to play with. But if you want to actually publish your code to DeepLens, it's quite a long-winded process. So first you've got to write yourself a Lambda function. Once you've written your Lambda function, then you've got to check it in your normal way to your source control. Then you've got to create a zip file of your Lambda function ready to upload. Then you've got to upload your zip file to S3. Then you've got to go to the Lambda console, use your zip file. Then you've got to create a new version of your function. Then you've got to go back to the DeepLens console, and you have a DeepLens project. In your DeepLens project, then you've got to go and tell it which version of your Lambda function you're using. And then you've got to deploy your project to the device. It's actually very easy to do this while skipping one of the steps. So I've seen people do this. I was just a hackathon the other day where there were teams using DeepLenses, and they weren't updating the project. So they're deploying code to their device. It's taking them a long time. They're trying to work out what's going on, and it took a long time before they actually came over and asked for help and said, I'm making all these changes to my code, but it doesn't feel like the changes are actually getting there. And it was just they'd missed a little step in the workflow to get the code on the device. So it's very, very error-prone, and it's a pain in the ass. And one of the things that I always think is things like this, it's too much like hard work. I can't be doing like that. I want to work on the problem rather than sort of dealing with cranking a handle. So I've spent a lot of time working on various DevOps projects, and hopefully some of my experience with the DevOps world can help make Internet of Things a little bit easier for me. So being able to automate all those things into a single script that I can run makes my life much easier. So firstly, what is DevOps? So DevOps, it's a cultural change for an organization, and it's all about thinking about how you can get things into production and release that value as quickly as possible. So being able to bring your products to market, and it's all about breaking down the barriers between sort of development and operations teams, and being able to just be much more responsive and iterative. So some of the things that is great goals to have when you're with DevOps for IoT is we want to get the value to customers as quick as possible. And also with IoT projects, quite often a lot of it is, it's very experimental. You're quite often using devices that may be at sort of the cutting edge of the field, and you want to de-risk your project as quick as possible. So ideally you want to prototype, you want to fail early. So some of the things that are very applicable is automating it and making it repeatable. Making your code testable is very, very important. Reducing that cycle time. So ideally as a developer, I want the time from I commit to my code to I get feedback whether it works or not to be as short as possible. And yeah, basically shifting left, so making failures as early in the timeline as possible rather than sort of towards the end of a project. And then the other goal that I care about is I'm lazy. I don't want to do a lot of boring, repetitive work. I want to work on fun problems. So the more automation of sort of the mundane, the happier your developers are. So quickly, why is IoT hard? So there are a few things that make IoT very, very difficult at the moment. One of it is it's not easy to deploy. You're dealing with physical devices. You're also quite often dealing with a small micro device. So this is very, very different to what you're used to these days. So the modern computer has so much power, really. It's growing exponentially, the power available to you to use on like modern servers. Whereas quite often with little IoT devices, you're playing with very, very small amounts of memory and not the most powerful processors. The other thing is, it's a physical device, it's a thing, so you're never going to be able to do everything within infrastructure as code. At some point, you actually have to leave your chair and pick up an actual physical device, which seems a little bit of a backward step if you've been used to doing stuff in the cloud. And then the other thing that's is a constant concern is how do you secure your devices. So why is it so difficult to deploy things? So a lot of people these days are working in the sort of web sphere, and quite often a lot of things that would have been apps a few years ago, people are actually deploying as sort of web products. And they're great. If you actually can deploy your project as purely something that your users will interact with through their browser, it means all your code is sitting on your server. You don't actually have to bother getting your code to the end user. Slightly easier than, slightly harder than browsers to deploy is to computers on mobile phones when you've got physical devices. In some ways, you would think mobile phones, I think, should be slightly more difficult. But I think mobile phones, because there's such a prescriptive way of doing things, so if you're using an iPhone, you're releasing your code via the App Store. That's the way to do it. Everyone's got the App Store on their device. Whereas if you're delivering your code onto desktop devices, still people are quite often getting software directly from vendors rather than from app stores or the similar. And then the most difficult thing is if you're trying to deploy to a thing, you now have to ship your code to a physical device. All this infrastructure doesn't exist for you. So you've got to worry about all that yourself. So very quickly, I want to touch on the idea of one thing that you should always think about very early in a project is actually your device selection. So there are quite a few different criteria that you need to think about when you're selecting a device. So I mean, one of them is the processor. More of what that will give you rather than what the individual processors do. But you find that the ARM processors, they're based on RISC chips. So they're very, very good at being very sort of power efficient. The Intel chips give you a lot more bang for your buck, but they're much more power hungry, and so they're not sometimes as good as portable devices. But then there are various advantages. So if you are trying to do things like machine learning at the edge, you might want to think about Intel chips. The other thing is, if you're depending on how many of these devices are you deploying a few hundred, are you deploying thousands? Cost can be a very important factor. How are you going to actually connect these devices to the internet? So are you going to be looking at something like Bluetooth Low Energy, LoRa, which is like a wireless standard, Wi-Fi, or sort of 4G connectivity? Where your devices need to be deployed quite often, so things like form factor or what sort of environmental conditions they're going to have to face, how you're going to power your device, and also normally you're deploying devices with some sort of connectivity in mind. So you want to be able to connect sensors to them, that sort of thing. So what are the capabilities of your device? Like, can you connect things like I2C sensors to them? So it's very early, I think, to make your choice of devices very, very early in the process. because quite often your whole approach will be based around the device, and if you don't choose the device early, quite often going back and changing this at a later time can actually be very, very painful. So then a little thing, one thing that's very good if you want to just get started, just a quick plug for one of my favorite devices to actually go and try out Greengrass is the Raspberry Pi. The Raspberry Pi is brilliant for getting to know Greengrass. It's quite a powerful device. It's got an ARM processor on it. You can very easily install Greengrass. It's running a version of Linux, so you can interact with it very easily. And it's got all sorts of input-output pins, so you can connect all sorts of peripherals or cameras to it. But having said that, that's a brilliant place to start. But one big warning is the Raspberry Pi was originally developed as sort of a STEM device, so it's for teaching and learning. It's not designed as a production device. So if you do want to use it as a production device, you've got to think about things like all its data is stored on an SD card. If that SD card wobbles out or something like that, which you will get in sort of field situations, that can be quite difficult. The other thing is it might not be as shielded or as heat resistant as some other devices. So you do really need to think before you go using a STEM device in a real world situation. So getting on to the reason we're here today, we're all here for an Amazon summit. So one of the best things to talk about is Amazon's part in the IoT ecosystem. So Amazon has a range of products which will make your IoT deployments much easier. So IoT Cloud, that's basically Amazon's hub where your devices will interact with the rest of the Amazon services in the cloud. Then normally on the ground you would have two different types of devices deployed, or two different categories. IoT Greengrass is quite often you would deploy one of those at a site as sort of a hub model. Greengrass is normally a much more capable device. You can Greengrass has things like Lambda built into it, so you can deploy your Lambda functions to your edge device, and you can run machine learning in Greengrass Core as well. And then you normally end up with, if you're running something like a production line, you'll have sensors all around your building. Quite often those will be much smaller devices because they might have to be squeezed into like parts of machines. And quite often you would use a much less capable device for those. And Amazon are helping you here as well. So Amazon have a couple of products in this place that you can use. So Amazon have done their own version of a product called Free RTOS, and there's also there is a Greengrass SDK which you can use so your products can interact with the rest of the Greengrass ecosystem. Most of the things talk together using a protocol called MQTT, which is a lightweight standard protocol that runs over TCP, and it's basically a pub-sub model with a broker. One of the things that your Greengrass core will do is it can be used to sort of buffer communication with the rest of the internet. So one of the things you do need to think about in IoT is you're not always going to be connected in a lot of situations. So getting on from that is how can we automate this when we've actually got physical devices? So one of the things is a lot of the Amazon products are very easy to sort of use infrastructure as code still. So there's quite often the way you set things up in AWS is for all your physical devices, you normally have something called a device shadow, which is sort of the representation of your device in the cloud. You can group your devices together so you can manage them as groups. So all of that sort of thing can be very well scripted using infrastructure as code. you can use Terraform or CloudFormation to a certain extent. The other thing that's very important to think about and very good to sort of think about from day one is over-the-air deployments. If you can use over-the-air deployments, not only can you then update your devices when they're in the field, you can also use that as part of your development cycle. So being able to push code onto your device from a CI/CD server once you've built it, it means it's much, much easier to actually script the whole end-to-end process rather than having to deal with the good old days of like having to flash a device or upload your code to an SD card and then copy it across to a device. So being able to sort of automate that end-to-end deployment makes your workflow much smoother. So one thing from my personal experience of trying to use some of this, I have found that CloudFormation does work much better than Terraform for the infrastructure as code things. If anyone else's experience varies, I'd love to hear what you're doing differently. But I've found even with CloudFormation, there are still some bits that you can't quite do using CloudFormation, and you will end up having to use some of their AWS APIs for a few things around like deployment and code signing. But it's very easy to build. Then the other thing that this sort of leads on to is how do you test your products. So there's testing of IoT devices is one area that I found to be quite a headache. So you've got a few different elements to test. So one of the things is for the Greengrass core, it's very, very easy to deploy Greengrass core in Docker, so you can actually run it on your machine rather than on a physical device. It'll give you a much better testing cycle than if you actually deploy it to the physical device, and you can run it on some much more beefy hardware. So you can get that feedback quickly. The other thing is quite often you need to test some of the bits that interact with the physical world. So there are sort of workbenches out there that you can use for testing some of the interfaces on your device. And then you can actually get an automated output, so making sure your device is sending the right signals to some of the sensors it's working with. The other thing that I found to be very, very useful is when you're writing your application, actually trying to abstract away a lot of the interaction with sensors and devices you're trying to control. So if you actually try and structure your code where you've got sort of your core application where the business logic is, and then make sure you've got your code structured so you've got just a few places where you can limit the interaction with the outside world, then it makes it much, much easier to use usual techniques like unit testing without having to worry that you're running it on a completely different device to your target really. So one thing, going back to how you're going to get your code there, over-the-air updates, when you're using an array of devices, you've got to be able to think about how you're going to update all your devices. So something like Amazon Free OTRS, which you can deploy on individual sensors, that has over-the-air updates built into it. Greengrass Core has mechanisms for updating it, but Greengrass Core is fundamentally running on a Linux operating system, so you've got to think about how you would update that as well, and trying to build that into your project is something that I think you've got to think about. And then any other components that you're going to use. So quite often you're going to be communicating back with the internet. Quite often you're not going to be able to update all your devices in a timely fashion. So normal processes like making sure you version APIs really does become critical to supporting devices. Next thing is monitoring. Monitoring is really essential during the development phase, but also to be able to support something in production, you really need to think through sort of your monitoring approaches. So if you're using devices that are interacting with the rest of the AWS ecosystem, so they're moving files to and from S3 or something like that, quite often you can actually use something like CloudTrails to see what they're doing with the AWS control plane. You can also use CloudWatch to be able to log events to CloudWatch and see what your device is doing. You can actually subscribe to the message streams that are being produced by your devices, so you can basically see what the communication is between the various parts of your system. Also, a lot of the things like Greengrass Core logs a lot of information to the local file system, so being able to actually get into the device and see what's going on in the file system is useful for debugging, but once you've got your devices out in production, if that was your way of debugging it, you will very quickly find that you have problems in a lot of circumstances. So the default logging setup is to log a lot of to the file system. If you leave that as is, you will quickly find that you cut yourself off from a lot of your logging options once you've gone into production. And then the other thing is, quite often with IoT projects, you can be dealing with vast fleets of devices. So quite often you need to look at something like dashboards to be able to have a holistic view of your entire system and what's going on in different areas. So actually thinking about that as part of your development is, I think, very important. So a few tips and tricks that I've come up with from doing this is, one, I found trying to stay within the Greengrass ecosystem for everything is quite important. If you try and do some of your project where you're deploying like code via Lambda and via the Greengrass ecosystem, and other bits where you're deploying your code through your own mechanism that you just want to run on your device in parallel, then you haven't got that over-the-air update infrastructure and everything else to be able to interact with it anymore. So if you want to go for a sort of a roll your own approach, you're losing a lot of the Greengrass value straight away. Like I said earlier, prototyping on the target hardware as soon as possible, I think, is very important. Trying to run your project just like you would a software project. I think making sure you start out from day one with the normal software hygiene. It is just code, so using source control, CI/CD is easier if you sort of start from the beginning. Another thing that I've seen a lot of people get bitten by is thinking about device longevity. A lot of devices people produce, is that device going to be around in a couple of years' time? If you're trying to deploy this at scale, can you get the volumes that you want? So there's things about, whether I can still get that device in a couple of years' time if I want to be releasing more hardware. How you're going to deal with software updates is a crucial thing. Code has bugs, everyone knows that. If you can't cope with bugs or new emerging security threats, you are going to find that you have problems. And also think about security for day one. So Greengrass has your back with that a lot. There's a lot of things built in like code signing and secure certificates for communication. So it makes it much easier to go that. So where have I got to with IoT and DevOps? So IoT as a whole field is very, very immature at the moment still. It's, there's no tools for doing a lot of this stuff, and I think there's a lot more work to sort of do in this area. So at the moment, you don't really have the facility to do zero downtime deploys. If you want to do something like that, quite often you would end up in a system where you can actually deploy multiple devices into your target location, and then you could deploy across them in waves, but you can't do zero downtime deploys within a single device. And I think testing is incredibly difficult with IoT devices, but that doesn't mean that the testing that you do doesn't have real value. So hopefully that's been a little bit of a flavour of what I've been doing with IoT and DevOps. And yes, if anyone's got any questions.
Any hands?
So you talked about the difficulty of keeping the same hardware in place over multiple years. Do you have a model for managing the same product stack on sort of an evolving set of hardware?
So there are a couple of different things you can do to sort of mitigate that. So a lot of devices that are out there that are the more commercial devices, they actually do, the manufacturers quite often will commit to, we're going to make this device available for 3 or 4 years, which is much easier than something like a Raspberry Pi, which is going to change every couple of years. So actually looking at that sort of thing that the manufacturers do is important. But the other thing is, at some point, your devices will have to update. If you only ever use legacy devices, you're not going to be able to use the sort of the new, better features that are going to become available. I mean, that's why devices fundamentally do change, because they've improved. So by making sure that you are sort of testing automatically, then you can automate the testing your code with like different green grass versions. Is the only thing you can really do to make sure that you can run the same code base across different devices.
You talked about difficulties in IoT applications. So how you deal with on-premises signal conditioning? And is there any software to sort such problem?
Sorry, I think
on-premises signal conditioning. Signal conditioning.
Sorry, it's just very hard to hear you. Because
yeah,
so
on-premises signal conditioning, so how you deal with signal problems on on-premises?
Problems. So the only way to really deal with that, I found, is to make sure sort of your device is and your systems are resilient. So when you design something for like production and IoT, you've got to assume that messages are going to get lost along the way. You've got to assume that it isn't going to be perfect. So ideally, what you want to have is your devices are able to carry on functioning as they were until they, if they're awaiting a message. You need to think about sort of how you deal with retrying, resending, and all those sort of things. And there aren't really a lot of frameworks at the moment for doing that in a great way, but it's something I think you've got to really make sure that you build into your application. And also you really do need to test with it, so you need to make sure that losses of connectivity, your device carries on running as expected.
Cool. All right, well, thank you very much for that, Andrew.